Here's more of angles and circles, intersecting lines with how they relate to the circles. Okay, we had that you can start, if you just take it as an angle, you can come in, it first intercepts a very small arc, it gets bigger and bigger until you get the middle. Then the definition of the measure of the arc is the central angle, so they're the same. Then you pull it back, the arc gets bigger, but the angle stays the same as it gets over, and it's inscribed, in other words, on the circle. Then it's twice as far into the circle, and the arc is twice as big as it pulls back. Then we look at it as not just of one vertex, but as two angles, intersecting lines, how that works. If they're here in the center, the two angles are verticals, they're the same, they intercept the same arcs. So you could rather obtusely say that add up the two arcs and divide by 2 to give you each of the vertical angles. That's useful because when we move it around the circle, we can see that as it moves, since the circle's round, the circle giveth and the circle taketh away. It stays the same. You can still add the two arcs, divide by 2, and get the angle, which is the same as the vertical. It's true no matter if it's an inscribed angle, if the intersection is inside, or if the intersection is actually at the edge and the angle is not inscribed. This would be a tangent of secant. Let's look what happens if the X marks the spot, the intersection is not on the circle or in the circle, if it's outside the circle. As we deal with that, again, they're going to continue to get bigger and bigger until finally the circle isn't even between my two lines at this angle. Well, let's see what happens first with a tangent and a secant. Okay. Now, as I look at this, I'm looking at this and I know certain things about it. For our purposes of this argument, I know the measures of the arc or the angle, but I'll know the measures of the arc between the intersections. So I'll know the measure of this portion, I'll know the measure here from the intersection to the point of tangency, and again from the point of tangency back to this intersection. So I know those measures, but what I want to know is the angle. And I look at that and I say, I don't know how I'm going to get that. I remember, however, that when I had an inscribed angle, it was like easy peasy, easy, easy, easy. It was just, I've got the measure of the arc and half of it is the angle. Well, lazy school of mathematics, if I can figure out a way to do that, find out what that arc is, and just divide by 2, then I'm done. So that's what I want to do. Well, let's see. If the angle were right there, it would be the same angle, right? Yeah. And then I could just take half of that, and that'd be the same. Okay. How could I make that happen? Remember back to parallel lines and transversals. If I put a parallel line right there, see that the angle that I want is the same as I just made with the orange and black, because they're what? Corresponding angles. Yes, indeed. So, if I can find this angle, then I know that one, because they're the same. That means I need to know this portion of the arc. Yeah, but I don't know that portion of the arc. I know the whole one from the intersection with black to the intersection with black. I don't know that portion. So is there a way I can figure it out? Well, let me think on it. Okay, well, I remember that foundational principle that circles are round. So I look and play for a moment and I say, oh look, looky, looky, looky. Since the circle's round, that means this curvature is the same as that curvature, and I've split it down the middle. This arc portion is the same as that arc. This arc is the same as that arc. Okay, well, I know this one to the left because that's between the intersection and the point of tangency. That's one of the things I know. This one I don't know. But I need to get rid of this one on the right because all I want is this portion. Remember, on the right, I know from the intersection down to the tangency. If I can get rid of this, then I know what I need to know, and then I can take half of it, and I've got my angle is the same as that angle, and I'm good. Okay. Looky here. This is the same as that. So just substitute it. Take the large arc and subtract the small arc, which is the same over here. That will give me the one that I need. So, large arc measure minus small arc measure gives me the one that's captured or intercepted right here. And that's the one I want. So once I get this, half of it is here. And, oh look, they're corresponding angles, and that's the angle I want. Ooh, easy way to do it. Well, kind of easy once it catches on to you. But anyway, it's a lot easier than trying to do something else. Because that intercepted arc, just take half of the arc, and it gives you the inscribed angle. That's just like too easy. So what do we have again? The big arc minus, not plus, the big arc minus, to get rid of it over here, the big arc minus the small arc is the one I need to get my made up angle, which is the same as the angle that I need. Just take half of it. So that works with a secant and a tangent. Okay, well, what if it's like this instead? Will my handy dandy trick still work? I don't know, but I'm going to try it, because you know what? This thing about the inscribed angles is just like too easy. You get the arc, you take half of it, you're done. Okay, well, let's see if I can do it. If I put myself a parallel line, it worked last time, maybe it'll work again. I put a parallel line here. Now, the angle I want to know is here. That angle, ooh, that looks like good. That'll be the same because it's corresponding. Again, I know between the intersections, I know this arc measure, I know this arc measure between them. I know the down here loop arc measure, and I know the arc measure up here. So I put in my parallel line. Why? Because I'm sneaky and because I'm a lazy mathematician. I know that when I do that, the angle I want will be the same as the angle I've just made with the orange line, because they're corresponding angles. Can I do the same thing? Again, who'd have thought the circle is still round? Okay, that means it's the shape. If I draw myself a little dividing line there so that I can see it, I'm looking and saying, oh wait, that little piece and that little piece are the same. Why? Because it's round and they're chopped off with parallel lines. Right there, that piece is the same as that piece. I know this one, and I know the big one. But what I want to know is just the part of the big one above the orange line. Can I get that? Yeah. I know the big one all the way down to here. And I know the little one. The two little ones are chopped off by parallel lines. They're the same. So big minus small, which is the same as the small one over here. Big minus small is the one I need. Half of it's the angle. The angle's the same as the angle. Yes, I'm home free. It works. Okay, good. What if instead of being a tangent and a secant are two secants, what if it's two tangents? What if I pull the angle back a little bit? I wonder if it'll work now. I have 2 points of tangency, 2 arcs between them, the smaller one here and the larger one here. Well, hey, you know, I've been having it made in the shade of a glass of lemonade with my little parallel line, and it just made my life a lot easier. I'm going to try it again. So I'll put my parallel line right there at the point of tangency. And this is looking really promising because this line is going to be the same as that again. Corresponding angles. Okay, so now what I need is just this part of the arc. Remember that I know the whole one between the point of tangency is the big one, and between the point of tangency is the little one. Oh, look. Again, the left is the same as the right. I wonder why that would be. I wonder if it's because the circle's round. Yes, indeed, the circle is round. This portion is the same as that portion. It's chopped with parallel lines. Okay, so what can I do? The piece I want is up here. Yeah, and what I've got is the little one and the big one. So I do the big one minus, again, the big one minus the little one, which is the same as over here. Big minus little. Take half of it. Ah, that's my angle. Oops, it's the same as that one. I'm done. I'm made in the shade with a glass of lemonade. It is good. I am done. And here's the theorem. Put it in your cipher. please. There we go. Okay, a little bit of practice about this. Here are some practice items. Let's see what we got here. Want to know what x is, how big the angle is. I know that the two intercepted arcs are 145 and 80. Remember, the circle giveth, the circle taketh away. Add them up to get the total that's intercepted. Divide by 2. You'll get a total of 230. Divided by 2 is 115. The measure of the angle is 115. Okay, how about this one? All right, now this is where I put in my imaginary little parallel line there, and I recognize that this arc, if I can subtract it, but I don't know what it is. How am I going to figure out what it is? Well, that's not hard. It's part of the circle, and there we go. So I'll just say, the whole circle's 360, so 360 minus 247 must be the small arc, which is going to be 113. So then what was my handy-dandy trick that I came up with for drawing my parallel line? It was big minus small divided by 2. Okay, the big is 247. The small is 113, and divide by 2. You work that out, and you're going to get that it is 67. Here's some more problems in case you want to practice. Get them going. Pause it if you like, and I'll put the answers up. There we go. Here's some more problems. They're kind of fun, like messing with circles. Give them a go, pause it, and work on them a little bit, and I'll put the answers up. And here are the answers. Here's some more problems you might want to work on. Well, let's look at one of them or two of them for this one. So here, remember that the opposite angles are the same. Didn't we already do this one? Here we go. Opposite angles are the same. Opposite angles are supplementary. So 180 minus 75 would be y, which would be 105. And you move on along around. You look at the rest of them, give them a try. Some of them are kind of fun. Figure them out. Pause in a minute, I'll put up the answers. Okay, here's the answers. And here's a problem that's a little harder. Challenge problem. See if you can get it. Pause it. I'll put up the answer in a minute. Here's the answers. And here's another one to give a good try to, having to do with the northern lights. Obviously, it's not drawn to scale because the Earth's a lot bigger than that. But give it a go, pause it and see what happens, and then I'll show you the solution. Okay, here's the solution. Remember, we don't use theorem numbers, but you get the idea. Okay. And here endeth the lesson.